Today we will be talking about the properties and structure of alkali metals which belong in group 1A on the periodic table. The alkali metals contain 6 elements that are malleable, soft, and excellent conductors of heat and electricity. These are lithium, sodium, potassium, rubidium, cesium, and francium, all of which cannot occur naturally by themselves and react vigorously with other elements. These elements contain very low densities and distribute the most similarities than any other metallic group. They also contain the lowest melting points, reaching as low as 27 degrees Celsius. These melting points decrease as we move down the group. Each element holds one valence electron in their outermost shell, which can be easily removed, allowing that electron to form an ionic bond with other elements. Alkali atoms have a diverse number of protons and neutrons in their nucleus, which enhances their reactivity when moving down the periods. According to chemistry education, an element's valence electron contributes to the development of a chemical bond with surrounding atoms. Potassium has a valence electron that is found further away from its nucleus than it is in lithium. It becomes more difficult to remove a negatively charged electron from its metallic bond if it is closer to the positively charged nucleus. This process is called oxidation. In order to determine how reactive an alkali metal is, one must observe their atomic radius. The radius can be found by dividing the distance between two connected atoms in half. Results would vary depending if the bond is covalent or ionic. Valence electrons will determine whether two combining atoms may form these bonds. Alkali metals have distinct physical characteristics such as having a silvery white color but tarnishes to a dull gray when exposed to oxygen and atmospheric moisture. This can visually indicate how reactive the metals are. According to Online Encyclopedia, the element that oxidizes the quickest will contain a higher reactivity. This was proven in an experiment at the University of Wisconsin. Potassium was the fastest oxidizing element and lithium was the slowest. Each element of group 1A gives off flammable hydrogen and creates an alkali solution when reacting with water, hence why they are called alkali metals. Their most prominent similarities are their low densities. All metals can be easily cut by a knife and float on water. These densities reach as low as 0.53 grams. The heavier the alkali metal, the more vigorous the reaction. Results would vary depending if the bond is covalent or ionic. Valence electrons will determine whether two combining atoms may form these bonds. The following trends in group 1A are placed in the order of lowest reactivity to the highest. As we move down the group, each element's valence electron moves further away from its nucleus, which makes it easier to remove. The energy in order to move a negatively charged electron from its shell is called ionization. Ionization is the process of consuming energy required to remove the most loosely bound valence electron. The speed of the reaction as well as the atomic radius increases as you move down the group. Halogen elements require one more valence electron to complete their outer shell. This makes halogens readily reactive with alkali metals. When an alkali and halogen atom bond, they create stable electronic configurations and form a substance called metal halides. According to Jeremy Harvey, an online chemistry teacher, alkali metals form monopositive ions such as Na positive when they lose their valence electron. Halogens form mononegative ions when they gain a valence electron. If a sodium atom bonds with a chlorine atom, sodium would lose an electron to create Na positive, and chlorine would gain an electron to create Cl negative. Lithium fluoride is the only hydroxide that is not deliquescent. Lithium is the second period in the alkali group and has an atomic number of 3. Although it shares similar physical characteristics as an individual, it displays several differences, such as the only one being able to form covalent organometallic bonds. The image above is a diagram of a lithium atom which contains only 3 electrons, including 1 valence electron. In contrast to other elements in group 1A, lithium has the smallest atomic radius of 1.67 angstrom. Lithium only appears in ionic compounds, although the element is classified as unstable. It has the strongest metallic bond out of all alkali elements.